Okay, we're going to be talking about now we're talking about the volume of cones, and just like in every other video that I've talked about as far as volume goes, volume of cylinders, rectangular prisms, triangular prisms, whatever, pyramids, I give a basic definition. And I'm sorry, I do apologize, my definition keeps changing a little bit the more I start thinking about things. And I'm, from one video to the next, I start remembering, I probably should have said it like that, or maybe I could have said that better. And so I'm refining it as I go. And I guess I should have maybe just looked it up in a dictionary, but I kind of find those dictionary definitions to be a little dry. And I like to have my own understanding for a definition of what volume is, for example, or what area is. And I suggest maybe you guys do the same thing. But anyway, so now the definition is that volume refers to the amount of space inside a three-dimensional object. And I don't think I said that before. I think I just said an object. And again, my water bottle, I always bring my water bottle. And it's something that it's like a container. But I also said that it could be a solid, okay? So that would be, that volume is the amount of space that an object takes up. How much space does that solid use up? So that's what we're talking about. Anyway, okay, moving on. So the formula for the volume of a cone has components from previous formulas that we've already used. And this is the formula for a cone, the volume of a cone. And you can see that we have this pi r squared. What's that for? What's pi r squared for? Your clue is the squared. Well, that's the area of a circle. Area, not volume, just the area, the flat surface of a circle. How much space is that flat two-dimensional circle? And then what's this formula? Pi r squared times h, or times height. That's the volume now, because we had the circle, which is area, multiplied to a third dimension. We're talking about volume at that point. And that pi r squared times h is the volume of a cylinder. And just like the pyramid, that was a three-dimensional box that got pinched into a corner, or into a point, right? It had it's like a cube, and those four sides come into a point, making a pyramid. This is a cylinder. Well, use my water bottle again, right? This is a cylinder that gets pinched into a point. And because they're both three-dimensional figures, the box and the cylinder, the three-dimensional figures, to get them into that point, we divide by 3 because it's a three-dimensional figure. Okay? All right. But again, so you can see how it's area of a circle, volume of a cylinder, then divided by 3, volume of a cone. So the formula isn't like getting radically different. We're just adding one more thing to it, okay? But it is important to understand what pi r squared is. What is that? What's it for? It is important to understand what pi r squared times h is. What's that for? And it is important to understand what the whole formula is for. Obviously, the volume of a cone. And I also said that algebra foo will be needed, okay? Your algebra foo, your kung fu, your algebra foo must be strong, okay? Because especially with circles, because it's circles and we're using pi, it's going to have a crazy long decimal. So for the most part, it's a crazy long decimal. And we'll be rounding around, we'll be approximating our answers. And because it's a square, sometimes we might have to do the square root. So that's what I mean by our algebra foo. We have to have good algebra. All right, so let's get started. Let's take a look at the first one.